Okay, let's see what's bisection method. It has a different name as well. What that is Bolzano method. It's also called Bolzano method. The basis for bisection method is intermediate value theorem. What exactly is intermediate value theorem is just I'll just make a mention of it. What that is let f of x be a continuous function. Be a continuous function in the interval, continuous function in the interval a comma b. Let's assume that it is a comma b. It's a continuous function in the closed closed interval a comma b. Okay. Now, what I'll be doing is, and we have f of a and f of b to be of negative signs. Negative. I'm sorry. We have f of a and f of b to be f of a, f of b are of opposite signs. Opposite signs. Okay. That means what? Just see here. F of a, opposite sign means what? One is positive, the other is negative. Obviously, plus into minus would be negative only, right? That is what? F of a into f of b is less than 0. Then, what this intermediate value theorem says is, there exists at least one root in the open interval AB. Open interval AB. Why? Because f of a and f of b are not 0. If f of a is equal to 0, a would have been the root. A would have been the root. If f of b is equal to 0, b would have been the root. Right? No, one is positive, one is negative. Okay, so between a positive and a negative only, root can be there. There exists at least one root in the open interval AB. Bisection method completely runs on this only. Suppose if, okay, what's bisection method exactly? Suppose if this is the interval. Suppose this is the interval AB. Okay, now f of a and f of b are of opposite signs. Okay, I'll assume that this is positive and this is negative. Either ways also it's fine. What I'll do, I'll bisect AB exactly into half. First approximation to the root will be a plus b by 2. Okay, now immediately I'll be checking f of x1. Now, if f of x1 is positive, then what happens? Between two positive, there cannot be a root. So I'll be going with this interval and bisecting. The next approximation to the root would be x1 plus b by 2. Okay. Yeah. Again, I'll be checking f of x2, which is again intermediate value theorem. Suppose if this is negative, okay, then what I'll do between a positive and a negative only, I can have a root. So I'll be bisecting x1 and x2. That would be my third approximation. x1 plus x2 by 2 would be my third approximation. There's nothing like a recurrence relation for bisection method, but then it is like whichever function values are opposite sign, that in that interval, I'll be searching the root, because between two positives, I can't get a 0. Between two negatives, I can't get a 0. I can get a 0 only between a positive and a negative value. Okay. With this, we'll proceed to one problem on bisection method. Do remember intermediate value theorem. There's a problem on bisection method. Find a positive root of the equation x cube minus 4x minus 9 is equal to 0 using bisection method. I have made a mention that 4 iterations I have to carry out. That means what? Apart from finding the interval, I have to find out x1, x2, x3, x4. This is one version of asking, guys, or there will be one more version. That would be what? Find the root up to 1 decimal accuracy or 2 decimal accuracy, they can say. Okay, find the root up to 1 decimal accuracy. What that is, I'll discuss. Okay, decimal accuracy. What is that? Let's see. Now, to find the root, what I should do? First, I should be finding f of 0. I should start with f of 0, f of 1 and all that. Okay, f of 0 would be what? Negative. Okay, I'll be finding the values, by the way. Here, it is 9. Minus 9. Okay. F of 1 is also negative because 1 minus 4 minus 9 would be minus 12, which is negative, right? Right. Now, f of 2 would be what? F of 2 is 8 minus 4 twos, 4 twos also is 8 minus 9. So, again, it would be what? Negative. Okay. Coming to f of 3, it can be positive. What would be f of 3? 27 minus 12 minus 9. This would give me a positive value. So the root of the interval, what is it? There's a negative and a positive. So root lies in the interval 2, 3. Okay, in the open interval 2, 3. So what do I do? Using bisection method, first approximation to the root would be 2 plus 3 by 2, which would be what? 5 by 2, or which is 2.5. Okay, just see here. Always remember, whenever you are using bisection method, make sure you follow this format. What that is this is 3. 4 iterations I need now. So I have drawn the interval so long. Okay. Now, this is what? 2.5. Now, what you do, this is negative. This I'll be checking. And this is what? This is positive. Okay. So, I have taken f of 2.5. I'll be taking f of 2.5. You'll be checking. I'm using a calculator, which turns out to be negative. So, between a negative and a negative, I can't have a root. So, between a positive and a negative, I'll be having a root. So, x2, the second approximation to the root would be 2.5 plus 3 by 2. Okay, which would be what? 2.75. X2, the second approximation. What's this? 2.75. I'll be checking f of 2.75 again. Once I check, if I use calculator and check f of 2.75, this turns out to be positive, right? So what I should do? Between two positives, do I have a root? No. So what I'll be doing? This one I'll be considering. The next approximate, what I'll do here is f of x2, f of 2.75 is positive. Hence, root lies between. At every step, you will be writing like this. Hence, root lies between 2.5 and 2.75. Remember, it's an open interval. It's neither 2.5 nor 2.75. So, what I'll do? X3, immediately I'll write 2.5 plus 2.75 by 2. Okay, so this value would be what? I'll be getting it to be 2.625. Immediately what I'll do? I'll be checking f of x3. What would be f of x3? F of a 2.625. Of course, for the Newton-Raphson, you'll be needing these values. For bisection method, it's enough if you write the sign of it. Okay, I'll be getting something like minus 1.4121, which is negative, right? Again, you notate that here, please, so that you don't lose the track. What I've got here is 2.625. And this value is turning out to be negative. So again, this would be my interval. What am I doing? I'm clipping off or bisecting off every interval at every step using using intermediate value theorem and proceeding further. Third iteration is over. I've been asked to find till the fourth iteration. So hence I'll be writing, hence you should write at every step. That pictorial representation is anyways there. Hence root lies between 2.625 and 2.75. I'll be bisecting that. Okay. So what I'll be getting x4 to be as 2.625 plus 2.75 by 2. So this value, I'll be getting it to be 2.6875. Okay. Now guys, I've finished. I'm done with my fourth iteration. So the root is, I'll write the answer like this. The root is x is equal to 2.6875. Now coming to the second way of asking the question, how do I answer it? What's the question? I've been asked, find the root up to 1 decimal accuracy. What does this mean? 1 decimal, 2 decimal, 3 decimal. What does that mean is, see, I'll be checking the successive iterations. Okay, successive iterations. What are those? Just see here. X3, what I've got? X3, I have got it to be 2.625. X4, I have got it to be 2.6875. Can you observe here, guys, that after the decimal, 0.6 and 0.6, it's tallying, na? Is it not tallying? 0.6 and 0.6 means after one decimal, as the name suggests, one decimal means what? After the decimal, one position should coincide for successive iterations for X3 and X4. One after the other we'll be doing now. Those are called successive iterations. Iteration is that process which we same procedure is repeated again and again. Such a process would be called iteration or iteration. So X3 and X4, for X3 and X4, successive iterations, after the decimal, one place is coinciding. One place is same. If I go till X8, guys, second place also will coincide. X7 and X8, second decimal also might coincide, but we are asked to do only 4 iterations, or we are asked for only 1 decimal accuracy. So I'll stop here. What is 1 decimal accuracy? As the name suggests, after the decimal, one position should be same for 2 successive iterations. Successive what? Either X2, X3 or X3, X4, like that. Okay. For 2 successive iterations, 1 decimal should coincide. If you see X2 and X3, after the decimal, it's not coinciding. Okay. For X3 and X4, after the decimal, one position is coinciding. That's what 0.6 and 0.6 is coinciding. If you are asked for 2 decimal, then I'll be doing around 8 iterations by bisection. Of course, whereas Newton-Raphson needs only 4 iterations, 4 to 5 iterations in such a case, guys. That's the benefit of Newton-Raphson. Okay. Anyways, bisection is the easiest, most easiest method. That's why it's still there. Okay. We shall see one more problem in the next video. Thank you.